This week we're going to look at a specific application of artificial intelligence in a virtual human agent. And we'll have to present from Japan, we have the startup company Couger, and we have the CEO, Mr. Atsushi Ishii, and we have the chief blockchain architect, Mr. Kazuaki Ishiguro.
Hello.
And they have self-introductions, so I'll let them do the self-introductions. I think you'll see it on the next slide, but each person will give prepared remarks, then we'll all three come up here and do a panel discussion that will be very interactive with you. Thanks for coming, and Ishii-san, the floor is yours.
Yeah, thank you. Okay, let me introduce about our technology called Connectome. The pronunciation is Connectome. By the way, do you know the keyword Connectome? Please raise the hand. Okay. Connectome is a nervous system in human brain. We can see there something, and we can hear something, and we can touch something, right? But at the same time, we understand very complex situation. And this is because of Connectome in your brain. So that's why our product name is also Connectome, because our technology is combining IoT and other your five senses, and blockchain is as your nervous, and brain is as your AI, and of course robotics is like your body. So that's yes, Connectome meaning. Okay, this is today's index. And first, what interface do we need in the near future? It is my part. And for 20 or 25 minutes. And second part is how to ensure the reliability of data and AI. It is Kazuaki part after me. Yeah, let me explain by myself. I'm a co-founder of Connectome and the CEO of Kouga. Kouga is Tokyo-based startup. And Kouga is always developing, combining cutting-edge technologies, such as IoT and AI and AR, VR, like that. And my background is I was developing large-scale search engine in IBM or Rakuten. Rakuten is one of the biggest Ishii site, just like Amazon. Okay. And the Connectome is the next generation interface combining AI and AR and blockchain. So first, we will show you the, some video from movie.
Okay, it's ready.
It is, as you know, it's from Breadrunner.
And yet,
There are, yeah, AI, human-like AI is coming.
It was a day.
would you read to me? It'll make you feel better.
Yes. And it is very similar to our vision. Our vision is to realize this kind of human agent. And let's compare to current AI and virtual assistants. And current AI is for specific purpose and mainly for using the playing music and some searching, as you know. And in the future, like Breadrunner, the AI is communicate just like human, and it's very, very different. And why now? And let me explain the timing. And as you know, interface is changing from every day, and from PC and the smartphone and smart speaker. And the important thing is, according to changing the interface, the data is also increase. And at the same time, the data is changing to privacy data, right? If you use a computer, the privacy data is maybe your browser data or something like that. But if you use a smartphone, you upload your private photo, and also you use very often, so the behavior data is uploaded, and also GPS as well. And for smart speaker, as you know, smart speaker is on your room or your office. It's more privacy data. And at the same time, the situation is changing. And as you know, the mega player like Facebook and Amazon and Google has big data, big privacy data. And maybe you know the Amazon Alexa suddenly laughing and very strange. But nobody knows the learning data and the AI model. It's closed, black box. And of course, Facebook has many trouble recently. And at the same time, you know, the unspecified devices will be connected in the future. So this means the unspecified devices will connect, and the data connection will be real time. Real time means every devices have to analyze or execute some program. So that means we have to create some structure to make reliability AI and data. And the 5G is also coming. So people expect more rich interface and more real-time and rich contents. So that's the timing. So we are now developing the interface. It's called virtual human agent. Let me show you the demo. In now, virtual human agent recognize the person and connected appliance. And she knows the situation.
大丈夫だったよ。ちょっと来て。
And disappears the monitor, and she's moving to the airspace. And at the same time, virtual human detects the object, such as chair or tables. And if she finds the person, cross to the person in the airspace. And finds the chair. And of course, can talk to her. And now, walk towards the person. And it is working on smartphone, but we are testing for smart glass. It's more seamless. And it is for the big monitor.
友也さん、10分後にミーティング始まりますよ。
And virtual human knows the schedule.
石黒さんはそろそろ出発のお時間です。今日は暑いので気をつけて行ってきてください。
わかりました。
Yes. And other demo. This is the person try to move to the office with virtual human.
何してるの？
And cross to the person in the airspace.
こっち来て。
はい。
I'm now walking to the office with person, and she knows the space like that. In the
この椅
office,
子いいね。
also detects the objects.
この椅子いいね。
And there is a bottle.
飲み物どうぞ。
And yeah, you should drink.
この椅子いいね。
And disappear again. And this is real size. Life size.
鈴木さん、暑いのでエアコンの温度を少し下げますか？
Temperature
お願いします。
is changing.
はい。
Yes, this is virtual human agent. Yes, as you see, the virtual human agent processes sight and sound like human, and understanding space and object, and able to talk very smoothly, and real-time reaction, and have feelings, and memory, and emotion, and of course connected to IoT devices. And this is a big difference from other device like the speaker. And virtual human has facial expression, and body expression. So virtual human express complex situation to the user. And it is accept, decline, and positive, negative, like that. And this is potential of human-like interface. This is the conversation investigation. Yeah, when asking a person using virtual human compared to the only voice, and the response rate is increased, and the response time also increased. It's very impressive. And this one is for autistic patients talk to virtual human. In the investigation, 60% of patients respond that it is easier to talk with virtual human more than real people. Yeah, it's incredible. And this is different approach of Connectome. And you know, this is Amazon and Google has a big data, and this is a comprehension AI means if you understand something, human and the bottles or bicycle or cats or something like that. In that case, if you have big data, it's very easy to understand. So that's why Google and Amazon is mainly using machine learning, and they are very strong. Mainly answer is just one. And this part is gaming company is very strong. Remember, if you play the game, you can feel your teammate is really exist, and your enemy is really exist. So that your teammate is care about you, and enemy try to kill you or try to destroy the world. That's why you can enjoy the world. So this is very different. So our Connectome is combining these two technologies. So input and comprehension is using machine learning, and the decision making and the sharing human-like feeling is just like character AI and gaming AI. Okay, so let's talk about the virtual human architecture overview. Virtual human is structured from 4 blocks. First one is input and comprehension. And the second one is processing. And third one is make decision. And last one is output. Yes, it's a little bit complicated. Yes, for the input, vision is, for example, the object detection, and scenes, face, and pose. And sound is voice and background music. Touch is haptics, and IoT senses, like that. And the output side is human action, body expression or face expression, like that. And also IoT devices and service APIs. And the middle range is very complex processing and make decision. And it is from unconscious and emotion and personality and behavior. And let me explain details. Yes, for example, if you detect the cat, in that part, cat is understanding. And after that, unconscious area is working. In that time, semantic memory is working. It is cat. At the same time, episodic memory is working. If you love cat, the emotion is changing to happy and pleasure. But if you don't like cat, emotion is sad or angry, like that. And at the same time, the personality is selected. Personality means from your skill and your role or something like that. For example, if you see the cat and you love cat, so you love cat and you want to laugh or very happy. But if your personality, if your role is receptionist in the store, you remind, maybe it's difficult to, I can't laugh or something like that. It's connected. And so virtual human control their feelings. And after that, decision is executed. And behavior tree means what kind of body action is should be executed. And finally, it is connected. And output is will be executed, like that. Yes, and it is for categorize. And for the gray part is machine learning. And the point is machine learning is only one or two answers. But for this green or blue zone is have several answers, several options. And the green one is we are using the game method and game AI. And the green one is our original human-based science. Yes. So virtual human agent will be changing to part of the society, I think. So in that time, the use case is increase, like entertainment and assistant and spaces. And also, you can develop your original virtual human agent. We will provide the SDKs. Developer or designer or AI developer can create virtual human agent on the marketplace. And it is used for receptionist and car guide or game entertainment. It's, etc. And especially, the definition of car and mobility will change. Car will be autonomous car. This means you don't need to drive. So in that case, car is changing your room. So virtual human agent is also expected in this space. So let me show you the demo in car use case.
Training. Yeah. right.
The two
Let's
person
go.
is going to music fest.
Good morning, Jennifer. Ron.
Good morning. Morning.
You have been looking forward to today's music
And Virtual
festival.
Human Agent
Oh
knows
yeah. I'm so ready to see these bands.
they go to
It
music
seems
fest.
it's sunny around the venue.
Oh, that's great. Nice.
And also
I'm glad it won't
knows,
rain.
Let's play your favorite music.
weather.
Oh, thank you. Oh, nice. I like it. Ah, thanks. I have good taste.
Some of you don't have something to drink, but do you want to buy them at convenience stores?
See the who
No,
has
it's okay, thanks.
drink bottle.
Have you had your breakfast yet? Oh, no, I haven't. Do you want to get some breakfast?
There is a Ichiran ramen restaurant that Jennifer is very fond of 15 minutes from here.
Oh,
It's her
How
favorite.
about we try that?
sounds good to me. Yeah, sounds good to me too. Yeah, let's go.
Okay. Yoshi, do you know where the Ichiran ramen restaurant
And
in
Virtual Human Agent
Shibuya
asks
is?
to the driver.
Okay, I know.
Let's go eat ramen.
Yeah, like that. So it's a summary. Virtual human, a human-like interface creates a trusting relationship between human and AI. Yes, that's it. And of course, the multiple use case expand. And demand is increased, and diversification of VHA is growing up. And so AI is so many AI will be we need. So in that case, it is important to have a mechanism to create reliability of data and AI. So in this part, Kazuaki will explain detail. Thank you very much.
Thank you.
Hi. Did you guys feel like having your own virtual human? Yeah, I really do hope so. And this time, we're going to cover how blockchain ensures the reliability of data and AI. Does anybody know what is blockchain is? Can you please raise your hand? Okay, that's good. That's good. And also, I want to ask, how many of you have used AI in a daily life? Not many. What about like some Siri? Have you used Siri from iPhone? Okay, that's good. So the question is, how can you prove that those AI are safe to use? Or how can you prove that those AI is not sending private data to somebody else? So I'm going to point it out, the problem. So I'm going to cover the part. My name is Kazuaki, and I'm Chief Blockchain Architect at Couger. And they're building a platform called Connectome. And also, I started my career as a DJ in Hollywood when I used to, and then kind of like self-taught programming. Now, after coming back to Japan, I joined a couple, startup company, and then I joined Couger, and they're building a blockchain platform. So let's do a quick review of AI timeline. Just giving you some history of AI. So it's been a while. It started as artificial intelligence back in the 1950s. Okay, I think I should start up here, right? Okay, back then, that was really simple. It's called rule-based AI. And then the first breakthrough came out in the 1980s, which is called machine learning. What it does is subset of artificial intelligence. And the biggest breakthrough came out after 2010. It's a subset of machine learning, aka deep learning. So after deep learning came out, everyone started developing their own AI. Okay? So what is AI? What it does inside of AI? So after deep learning, you get the AI just like this. In other words, it's a trained model. And then train model doesn't do anything by itself. You're going to have an input, and then based on those input, AI is going to give you some output. Very simple. So input is going to comprehend. For example, you get some picture or some conversation or some text or whatever the thing is. And then AI is going to detect something, and then they're going to give you some output, which is reaction or evaluation. But between these two layers, there is a middle layers. We call it decision-making process. And this is where magic happens, because no one knows what is going on. No one wants to share inside the middle layers, because that's their business model, or that's the key of AI. And then this middle layer and input side has lots of problems causing today. Now I'm going to point it out one by one. The first one is black box data. I think Atsushi already mentioned, but I'm going to deep dive. So if you want to create some AI which is very precise and high accuracy, you're going to have lots of data sets, maybe 100 times more you imagine. I don't know, maybe more. And then data is not always clean data, so you have to have someone to clean those data sets, or you're going to have some big database to store those data. That's why data is really valuable. And then once you have valuable data sets, you don't want to share to somebody else because it has a value in it, right? And then it's going to cause a silo, data silo, and also black box, because of course you don't want to share it to somebody else. And then the economists already pointed out, data is new oil in the 2000s. And those tech giants already working hard to collecting those data sets, and as you already know, there's always a problem. So AI is not trustworthy. I think Amazon Alexa bug is a very famous one, and then the next one is the Google Home bug, which is they actually recording the home conversation and then send it to somebody else, which is on their address book, which is super scary. There's no privacy at all. And also the Uber autonomous car accident, maybe you might have heard or not. During the test of autonomous car driving, they hit the pedestrians, and then pedestrians died, unfortunately. But they don't reveal the problem. Is there any bugs or any, I don't know what was going on. They just press release, okay, we'll fix it. Don't worry about it. You are now safe to use our AIs. But we should know what was going on inside, but there's no way. So that's the problem. So we have developed some technology called, we have developed some application called Geneflow, which is a system that records the learning and the execution history of AI in the blockchain and ensures the reliability of AI. The Geneflow name because we can track and trace the growth history, so it works like a family tree. And then once you get the parents' AI, you can, once you got newer transfer model, you can always trace parents' models. So that's why we name it Geneflow. So before we get into the Geneflow, we want to quick review. I want to quick review the blockchain. What is blockchain is? Oops. That's good. The blockchain is literally, it's a chain of blocks which contain the list of records transactions. Okay, and it's decentralized and the distributed and public digital ledger. The most important part is the once transaction stored in the block, it's immutable, which means you cannot change once you have created some records. And since it's a distributed ledger, once you have deleted some data or blocks, it never gone because somebody else has it. So that's why it's secure the network. The other important part is smart contract. It's simply the computer program stored inside of the blockchain. Because it's stored in the blockchain, it's also immutable and distributed, which means you cannot change any codes once you have created those smart contracts. So that's why it's so secure, right? Okay, I would like to go over more and more because I'm a blockchain architect, but that's another chance, I guess. Okay. So how Geneflow apply in the Connectome? Mainly Connectome, Geneflow will be applied in the comprehension AI side. Connectome has produced some virtual human agent, and the core technology on the comprehension side is used by Geneflow. Okay. So why you have to have blockchain technology in the Geneflow? Can we create it by centralized server, or can we create it like Amazon or Google? So let's compare. The one in the red part is a centralized server, just like tech giants do. They store the data in the black box, and then also they store some algorithm because they don't want to share somebody else, and then they install it into some AI or devices. For example, Amazon Alexa or I don't know, iPhone Siri or some kinds of AI installed devices. But they release, okay, we have open datasets or open algorithm we have installed into the devices, but there is no way to prove that, right? On the other hand, the decentralized, if we apply some blockchain technology, we have learning data sets. You can always check what kind of data are there or what kind of algorithm are there. Also, we have traced the history of learning data and algorithm. And then once we have installed into the devices like this, you can always trace because of the transaction histories. So we have AI or machine learning data sets, algorithm, and then train model. So once we have created some data, and then we store all the data and algorithm and train model into the blockchain. And then if you have another data sets and train algorithm, we all store into the blockchain. That's why you can trace the history of the growth of AI. That's why it's so secured. And it's open data sets, so you can always check back. If you got a new iPhone, okay, what kind of AI algorithm are there? You can always check back if you are using a blockchain technology. Okay. So let's coming back to AI outline. Okay, now we have input or comprehension side. Comprehension AI are safe to use. Okay, what about these two? The middle and the output layer. Can we open those layers? I guess we can do, but no one does. That's why causing a problem. So AI problem number 2 is algorithm. This is what it looks like on the middle layer and the output layer. So decision making and the action process is simple like this. If my AI or trained algorithm, trained model have received input A, input something, and detect something, and do this. Very simple. But from our point of view, it looks something like this. It's in the black box. and that it seems like magic is happening inside of AI. You only get the output, right? And this is what happens when some journalists ask Sophia the robot, I will destroy the humans. But we don't know why she made those kind of decisions, right? Because my algorithm says so. So this is a problem. This is scary, right? So we set some kind of use cases to tackle this problem, which is the smart space use cases. So for example, if my trained model have detect seated person without something to drink, do something. So please be careful watching the this output part, what she is going to do, what our AI is going to do. And this part is our meeting room, the people sitting, right? Detect the person, and then the some pose detections. This is a computer vision, by the way. And then this is our office, and then detecting a bottle of water or tea, and then we have a person, and stuff like that. Okay. So 2 persons came in, and they sit.
Kojiru, the number of people have been increased in the conference room. They may stay long because they have seated. Why don't you take some drinks for them? You need 2 of them because we have 2 more people.
Sure, will 2 bottles be enough?
Yes, please bring 2 bottles.
Okay, thank you.
Thank you, Kojiru.
So yeah, she detected 2 more persons in the meeting room, but they don't have any something to drink. So our AI detects someone in our office and they ask him to bring some bottles. Okay. Good job. Okay. And then this is our architecture of our smart home use cases. So we have sensor to detect someone in the room. And then once we have take some pictures or some videos, went through the AI nodes, and we have image and the metadata, which is we have person or sitting or bottles or whatever. That's the metadata here. And then we send it to the master server and then store in the blockchains here. Okay. And the most important part is smart contract here, and also this part. So this is the input part. If there's a seated person without something to drink, let the virtual human find someone in the office and suggest the person to bring bottle. We store this algorithm into the smart contract so that everyone can check after the virtual human made the decisions what was going on inside of her. You can check on the smart contract because it's stored in the blockchain in the public ledger. So coming back to this outline, it's now safe to use everything. Input, middle layer, and output layers. And this is our virtual human agent. Having, ensure the reliability. So in the future, as Atsushi explained, we are going to provide some SDK so everyone can have your own virtual human. You can develop by yourself or you can purchase from someone else. And we're going to have tons of many virtual human agents, which is good. Okay. So, but once we have lots of virtual human agent, the next question is how can we find my perfect virtual human agent? How? Or I need some virtual human agent for a specific for my use cases or something. Or some of the virtual human agent have the bad algorithm. Or if you are developers, that's okay. But if you're not developers, I cannot read some code, and I didn't know how they're going to act, how can we know? So the next challenge is how to evaluate virtual human agent with diversity. For the classic approach is using a search engine like Google or Amazon's. Is it still safe to use or maybe not? So this is an example using a centralized search engine. Okay, we search, let's find best self-driving car AI or virtual human agent. And then always we have 100,000 results. And then there have some lists of a search result. But problem here is sponsored content has always priority. They're always coming on the top. Or they have applied some techniques to search engine optimization, or we don't know, some black box filtering algorithm inside of the search engine. Or as they pointed out, they have 5 stars AI, but how can we trust those feedbacks? So we are going to use the decentralized evaluation system, which is called Connectome Marketplace. It's decentralized market platform for virtual human agent. And any developers can create their own virtual human functions or interfaces. And marketplace is maintained by community, because community is stronger than economies, right? They have mission and vision to maintain these communities. And inside of this marketplace, we are going to apply some incentive mechanism to maintain these networks, and also self-sovereignty and cryptographic proof. Okay. So this is an incentive mechanism, example of an incentive mechanism created by Joel Mongero from some blockchain researchers. And we have creator and users and investors. And then these 3 parties work together and closely, because currently the equity and the work is separated in the company, right? But in this crypto economic activities, put these 2 into one big thing. So this is how community works with an incentive mechanism. And the one example of a search engine in a decentralized way is called Token Creator Registry. It's also called TCR in short. For example, if you are virtual human developers, we have created some new virtual human to sell it on the marketplace. So if we want to sell it into the marketplace, to be on these lists, which kind of like search engine results, you have to have stake some tokens to be on the list. But there is no control after you propose the new virtual human. Who's going to evaluate? There's another parties, which is virtual human critics or enthusiasts. So they're going to vote this proposal with staking the tokens. So if they lie, they're going to lose some tokens. So there's no incentive to tell a lie. Or if you don't agree with these new proposals, you can challenge to find better virtual human in the market. Okay, the virtual human you have created is cool, but not precise enough, not looking good, or there are better algorithms in the market. I will find it, so I'm going to challenge you, staking with the token. And of course, virtual human agent users are free to read these lists. And this is how community works in a decentralized way. So as I told you, communities are very stronger than economies. So we are really focusing on community development recently. We have done a virtual human hackathon with some other project from Berlin called Ocean Protocol. So we have set the selling point, the best virtual human customer service. And then all the developers apply to be on the list, which is smart function, root functions, or whatever. And then some other party is going to vote, okay, I need this function on the best virtual human customer service, and stuff like that. And then it came out really good, brilliant. And also we have done lots of community development all over the world. So we are focusing on all the developers, all the people is going to use our marketplace to develop their own virtual human and sell it to somebody else without trusting us or without trusting some other parties. So that's the future that we are looking at. So I'm very excited to provide this service in the future. So that's it from me. Thank you very much.
Great, thank you.